First question on the review sheet says, use your calculator to approximate the value to 3 decimal places. So we're asked to evaluate e raised to 4.3. So we go second e to the x, plug in 4.3, hit enter, and to 3 decimal places we would have 73.700 because that would round up. So 73.700. Next up, find the value of an investment of $20,000 at 6% interest compounded semi-annually for 13 years. Since we're compounding semi-annually, we want to use this equation. We only use the PERT equation if we're compounding continuously. Our principal is $20,000. Our rate is 0.06. We're compounding semi-annually, so that means twice a year, so n is 2. And we're doing it for 13 years, so that's our time. So all we have to do is plug this whole thing in the calculator, and it should tell us how much money we'll have after that amount of time. So 20,000 times 1 plus 0.06 divided by 2 raised to 2 times 13. Giving us $43,131.83. When it's money, always just round to the nearest penny. So $43,131.83. Number 3. Akela Ingersoll is deciding between two investments. Account A offers a rate of 5% compounded daily. Account B offers a rate of 4.9% compounded continuously. If she has $300 to invest over 10 years, which account will earn her more money? So remember, for compounded daily, we use the same equation I did on the previous one, where this time our principal is 300, our rate is 5%, we're compounding daily, so that's 365 times a year. And our time is 10 years. So let's go ahead and plug that in and find out what account A gives us. 300 times 1 plus 0.05 divided by 365 raised to 365 times 10. So that would give us $494.60. That's account A. And now let's try account B. Account B, we are doing it continuously. We're compounding continuously, so we use this equation. Our principal is still $300. Our rate is 4.9%, or 0.049 is a decimal, and our time is still 10. So let's plug this in, see what we get. 300 times E raised to the 0.049 times 10. So you get $489.69. So account A is better. Okay, here we just need to plug this in our calculator. We could do alpha F2. Use number 5, that's log base. We plug in log base 2 of 16, and we get 4. Okay, this one we have to solve, and this is not 5.7, this is question number 5. So it's 7 raised to the 0.3x plus minus 1 equals 812. So our first step is to add 1 to both sides. So we get 7 raised to the 0.3x equals 813. Our second step is to take the natural log of both sides, because we need to get that exponent out of the exponent, or the x out of the exponents. And the natural log allows us to do this because one of the properties says you can take an exponent and move it down as a coefficient. Divide both sides by the natural log of 7. Let's go ahead and do that in the calculator, see what we get. Natural log of 813 divided by natural log of 7. You get 3.443. And then we divide both sides by 0.3. So our final answer is going to be this divided by 0.3, which gives us 11.478 is our final answer. Number 6, we need to solve this. Well, we need to get rid of the logs, but we cannot get rid of the logs when there are two of them. So we need to combine them into a single logarithm. If you remember, addition can be changed into multiplication. So it would be x minus 2 times x plus 2 equals 2. And the way we get rid of log base 5 is by making both sides powers of 5. So that cancels this out, leaving us x minus 2 times x plus 2. 5 squared is 25. If we FOIL all this out, do all that mess, you should get x squared minus 4 equals 25. Add 4 to both sides. So we get x equals the positive or negative square root of 9. Square root of 29. And while we get both positive square root of 29 and negative square root of 29, we can't use the negative one because if we try to plug that back in, we end up trying to take the logs of negative numbers, and we can't do that. So we'll only use the positive square root of 29. Number 7, pH is equal to negative log of x, and that measures the pH of a solution where x represents the concentration of hydrogen ions in the solution in moles per liter. Use this equation to answer the following questions. Round to 2 decimal places. Find the pH of a solution that has a hydrogen ion concentration of 7.9 times 10 to the negative 4. So we know pH is equal to negative log of x, and we're told here that our log is 7.9 times 10 to the negative 4. So let's go to our calculator. Negative log, this is the common log, not the natural log, times 10 raised to the negative 4. So you plug it in just the way it is, and we get a pH of 3.10. Number 8, what would be your hydrogen ion concentration of acid rain with a pH of 9.3? So again, the equation's pH equals negative log of x, and if we have a 9.3 pH, we multiply both sides by negative 1. And then remember, when there's no base written, it's understood to be 10. So the way to get rid of that is to make both sides powers of 10. So just cancel that out, plug 10 raised to the negative 9.3 in your calculator, and you get your answer. And you can actually just leave it as 10 raised to the negative 9.3 if you want, or do this 5.011 10 to the negative 10th.